Okay, welcome to Chapter 4, Lesson 7, Linear and Nonlinear Functions. Our learning target or objective for this lesson is to determine whether a function is linear or nonlinear. And we have one vocabulary word for this lesson, nonlinear, which means functions whose rates of change are not constant. Okay, when we learned linear functions, we had a constant rate of change. And now for nonlinear, we're going to have the rates of change are not constant. Okay, write down the vocab, pause the video, and may continue once you are done with your vocab definition. Okay, we're looking at example. The table shows the approximate height and horizontal distance traveled by a football kicked at an angle of 30 degrees with an initial velocity of 30 yards per second. Okay, we have a couple questions about this graph and table. Did the football travel the same height each half second? Did the football travel the same length each half second? Okay, so we have to graph the ordered pairs of time and height and then time and length on separate grids. We're going to connect the points with a straight line, and then we're going to compare them. So, okay, first we're going to do the height of the football. So once you're going to have to label your graph, let's label those. Everyone's going to be at 0.5. That's a 1. 1.5. 2. 2.5. 3. 3.5. 4. And that should get us enough to where we need to go there. And each one we're going to make by 2, 4, 6, 8, 10. Okay. On y-axis, this is our height on this side. And time is our x-axis. Okay, looking at our points. First, we have 0, 0. Ball started out at no height with 0 time. 0.5 seconds. It was up to, let's put a 12 in there just in case. 0.5 seconds. It was at 6.2. After 0.5 is right about there. At 1 second, it was at 9.7, just below 10. At 1.5, it was at 10.5. Let's go right about there. At 2 seconds, it was 8.7. So a little bit coming down. And 2.5, we're at 4.2, right about there. So just gonna connect our dots. The ball's going up and coming back down. Okay, that shows our time and height graph. Let's slide over to the other one. We're gonna do time. Once again, is on our bottom, and the length is our y. We're gonna do, once again, each one 0.5 and 1, 1.5 and 2, 2.5 and 3. And our height, length, we're going to go by tens. 10, 20, 30, 40, 50, 60, and 70. Okay, now we're going to look at our ordered pairs. First, we have to start out at 0, 0 with the length and the time at 0. And we have it 0.5 and 13. 0.5 and 13 right about there. 1.5 and 39. I'm sorry, 1 and 26. Let's do 1 and 26. Right about there. 1.5 and 39. Right about there. 2 and 52. Okay, whoops, a little high. And 2.5 and 65. Right about there. Now let's draw a straight line. And there we can tell Okay, with the time and length, we have a linear function. We have a straight line. And the time and height is showing a nonlinear function. So you can see the difference between the two. The constant rate is different for the time and length, time and height, I'm sorry. Okay, so let's look at our questions. Did the football travel the same height each half second? And obviously, no, it did not travel the same height each half second. Otherwise, it would keep on going up and up and up. So that would be a no. Did the football travel the same length each half second? Yes, and looking at this, from 0.5 to 1, it went plus 13. From 1 to 1.5, it went plus 13. From 1.5 to 2, plus 13. So yes, it kept on going plus 13, so it was a constant change. So that would be a yes. It's a constant change. All right, let's look at some more examples for linear and nonlinear functions. Okay, determine whether each table represents a linear or nonlinear function. Explain. Okay, we're going to look at the first one. Let's look at our x's. Our x is 0 to 5, plus 5, 5 to 10, plus 5, 10 to 15, plus 5. Got our y, 20 to 16, minus 4, 16 to 12, minus 4, 12 to 8, minus 4. So we have a constant rate of change there. So this table would be linear. Okay, let's look at our second table. X is 0 to 2, plus 2, 2 to 4, plus 2, 4 to 6, plus 2. Okay, so far that looks constant. Let's look at our y's. 0 to 2, plus 2, 2 to 8, plus 6, 8 to 18, plus 10. So just right there for the y's, they are not constant. We didn't have a 2, so this table would show us a nonlinear function. So it would not be a straight line when once graphing this equation. Okay, let's look at our next example. We're going to look at a real-world example. Okay, a square has a side length of s inches. The area of the square is a function of the side of the length. Does this situation represent a linear or non-linear function? Please explain. So let's look here. We're going to make a table to show the area of the square for side lengths of 1, 2, 3, 4, and 5 inches. So this table, once again, is an ordered pair. The side is going to represent our x's. Our area is going to be our y's. And let's mark these every other one. We go 2, 4, 6, and every other. Let's go 10, 20, 30. This shows our area. This shows our side length. Okay, we're just going to graph our points from our table. See if we have a linear or nonlinear function. Our first order pair right here is our 1, 1. 1, 1 would be right about, yeah, that's a little high, but off a little bit. Next order pair, 2, 4. And right about, it's a little high, but close enough. Next one is 3, 9. There, we have 4, 16. We're going to be up here a little bit. And on the last one, we have 5, 25. 5 and 25 is going to be up here. So let's just graph this out. Graph it out. We notice we're curving upward, even though it's not the best line in the world. We can still have We know it's not a straight line. So obviously we can tell that this function is a non-linear function. Constant rate. Let's look at our side. Let's look at our table real quick to see, make us the double check to make sure our graph isn't just misleading us. Our stride length +1 is 1, 3 to 4 is +1, 4 to 5 is +1. Well, that's constant. Let's look at our area. We have a 1 to 4, which is a +3 difference. 4 to 9 is +5. 9 to 16 is +7. 16 to 25 is +9. So we really don't have a constant rate there. So yes, that does double check our graph. That's showing us we have a non-linear function. Okay, any questions concerning linear and nonlinear functions? Please write them down. We'll go over them at the beginning of class, and then we will work on our activity in class.